Hello and welcome to yet another video of Cornerstones of Math. Today we will find the minimum value of these functions. And without further ado, let's get started. The first one seems quite obvious. We have repeating parts x squared plus 1, so we can make a substitution to simplify the expression. So let x squared plus 1 be the new variable t. Then y equals t squared plus 4t plus 5. This is a quadratic function of t, and we can easily find its minimum value by completing the square. That is, y equals t plus 2 squared plus 1. So from the graph of quadratic function, y is minimum when t equals minus 2, and the minimum value is 1, right? Well, no. The thing is, this t is x squared plus 1, so t cannot have the value minus 2. In fact, from the graph of x squared plus 1, we can find out that the least possible value that t can have is 1. Therefore, if we express y as a function of t, we have additional condition that t is greater than or equal to 1. Which leads to this very important general principle when making a substitution. Whenever you make a substitution, be careful with the range of the newly introduced variable. Therefore, if we search for the minimum in this domain, we can see that y is minimum when t equals 1, and the minimum value is 1 plus 2 squared plus 1, which is 10. For the second problem, first, let's change this cosine squared x into 1 minus sine squared x. Therefore, we have sine squared x plus 4 sine x plus 5. Now the function is expressed in terms of sine x, so we can make a substitution sine x equals t. Then, y equals t squared plus 4t plus 5. This is the same quadratic function as in problem A, so we can complete the square in the same manner to obtain t plus 2 squared plus 1. And here comes the range consideration. Here, t equals sine x, and since sine x has a range greater than or equal to minus 1 and less than or equal to 1, we have the range condition t is greater than or equal to minus 1 and less than or equal to 1. Therefore, if we search for the minimum under this condition, y is minimum when t equals minus 1, and the minimum value is minus 1 plus 2 squared plus 1, which is 2. For the third problem, let us manipulate the given expression a bit. This 4 to the power of x can be written as 2 squared to the power of x, and this 2 to the power of x plus 2 can be written as 2 to the power of x times 2 squared, and this 2 squared to the power of x can be also written as 2 to the power of x squared, and for the next term we can write 4 times 2 to the power of x. So now we have the common part 2 to the power of x. So let us make a substitution 2 to the power of x equals t. Then y equals t squared plus 4t plus 5, which is the same function as we've dealt in previous problems. So y equals t plus 2 squared plus 1. Here, t equals 2 to the power of x, and since 2 to the power of x is greater than 0 for all real numbers x, we have the condition t is greater than 0. As you can see, the value of y decreases as t approaches 0. But since t cannot become exactly 0, meaning that there are no such real numbers x that makes 2 to the power of x 0, y cannot have the value that occurs at t equals 0, which is 5. Therefore, in this case, the minimum value does not exist. I mean, if we consider about the limit of y as t approaches 0 from the right, then the value of this half limit exists and it is 5 because the limit approaching 0 does not require that the function should be defined at 0. Also, for some of you who are familiar with the concept of infimum, then you can say that the infimum of y in this problem is 5. However, as for the minimum value, it does not exist here when it ends in an open interval like this. Now before I wrap up this video, I want to emphasize again that whenever you make a substitution, you should always check the range of the newly introduced variable. And that's all for today's video. Thank you for watching and I will see you in another video.